Yes. 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 Right. Yes. Right. Now time is exactly 2. We'll start at 8:05. Today plan is now revision cover up both. So we can do the same thing, ne? So good morning. Good morning, everyone. Uh, we'll start at 8:586. So what you can do, you can take a cup of tea. While drinking the cup of tea, you can watch like me. Like me. I'm almost finished. Right, okay. Now we'll work. Yesterday, planned to do this session but could not do because I had to do some projects in my factory. Therefore, so I came a bit late. So with that tired, I know that even I do the class yesterday, I won't be able to do it with my maximum. Right. So anyhow, it's okay now. Today plan is now this is most important two sessions. You need to linear motion and vertical motion under gravity because this is important. No matter even we do upcoming sections also. Sometimes let's say even heat. You need for heat And unit 3, oscillation and waves, some parts. We need unit 2, linear motion equations, right? S equals UTO, other linear motion equations we need. Even we solve unit 3, unit 4, sometimes unit 6 questions also. So therefore, you should know about this section properly. This section is very important section. Okay. Now, what I do, I just share some PDF. Now, linear motion, I think in the group, you could see that linear motion, that PDF. And also there is vertical motion PDF. So we can't take a long time and we can't discuss linear motion. In 26 theory class, we took around 3 to 4 weeks to discuss linear motion. And again, 2 to 3 weeks for vertical motion under gravity. But in this scenario, we are not able to take that much of time and we can't revise them in 25 revision class as well as 26 cover up class. Because here, what is the intention? Quickly summarizing what to be learned, what is important, we summarize it and we learn. But when I do that summarization, I try maximum to make everything well explained. I try maximum to make everything well explained. That is my responsibility. Okay. So what we do, I briefly discuss all the important points. Parallelly, what you can do, I am doing 1 2 questions, but I don't do plenty of questions. We don't have time. That is the plan. Okay. So now what we do now, just quickly take that PDF, linear motion. What you should know in linear motion, right? Then we discuss dimensions, vectors. I give the idea, dimensions, vectors, and for 25 revision, solid expansion we learned. And today we are discussing linear motion and vertical motion, right? Okay. Now, okay. Now we know that when we learn about linear motion, there are 5 or 6 important physical quantities that we should know, right? Because you know what is physical quantity. We learned that before. I'm not going to explain what is physical quantity. But when learn about linear motions, we should understand about distance. We should know about what is distance. If I say distance, you should feel. Distance means something this. And displacement, then speed and velocity, acceleration, deceleration. If you learn acceleration, negative acceleration is we defined as deceleration. So therefore, acceleration and time. So what we should know when learn about linear motion, we should know about distance, displacement, speed, velocity, acceleration, and time. I'm not going to explain anything about time because we know what is time. Time is measured in seconds. If not, we can measure in hours or minutes. And time is a scalar. We don't discuss anything about time. It's not that much to discuss. Now, first we should understand what is the main difference between distance and displacement. Okay. The symbol to represent distance is simple d. Simple d. Distance. Symbol is simple d. I don't want to explain this, but it's okay. I quickly brief it. Now, distance means just think there's an object. Initially, object is at A. You are at A. Then what you do? Now you move. Right? You are moving from point A to a point capital B. Now, initially you are here. Now you moved from A to B. Final location is here. So I can say this point as initial point. Final point is, this is your final point. Initial point, final point. When I track the path that you traveled, if I track the path that you traveled, this is the path that you traveled. Okay. This is the path that you traveled. Then what is distance? When you measure the length of the path. If you can measure the length of the path, that is what we defined as distance, right? Simply, distance means the length of the path. So then you know what is the units to measure distance? Meters. Dimensions, capital L. Distance is a vector or scalar. Since distance is a length, that is a scalar. That is the important things you should know about distance, right? If you measure this length of the path, that is we defined as distance. So units, units meters, dimension capital L, it's a scale. So this is what you should know about distance. Nothing they have to explain. But you should aware how to differentiate what is the main difference between distance and displacement. Because both the physical quantities are behaving very similar manner, but there's a significant difference between displacement and distance. Now, how do we define displacement? How to define displacement? Notation is capital S. Distance simple D. Displacement notation capital S. Now we define displacement as again, initially you are at point A. You want to reach point capital B. If I track the path that you traveled, this is the path that you traveled. If I follow behind you, this is the path that you traveled. This is the path that you traveled. Okay. So then if I measure the length of the path that you traveled, that is what we identified as distance. Displacement means, remember, from your initial point to final point, the shortest distance. But you know that. So this path is not the shortest distance between A and B. Am I correct? There are possible short paths between A and B. Comparing with the path that you traveled, I can say this path, this red color path is bit shorter. Okay. Now this red color one is not a straight line. When you compare with this blue color path you travel from A to B, I can say this red color path is a little bit shorter than blue color path. But what is displacement? Remember, the shortest from between 2 points, initial and final point, the shortest distance is what we defined as displacement. But remember, between 2 points, shortest distance means always a straight line between those 2 points. Okay, no matter whatever the geometry that you draw between A and B, it can be a curved one, it can be a what, it can be some kind of rectangular one. No matter, you can draw plenty of paths between A and B, but remember the shortest distance always will be the straight line connected initial and final point. So remember, always displacement means, remember, the shortest distance from initial point to final point. Right? So then always remember, displacement means shortest distance from initial point to final point. Then point A is initial point. Initial point. Point B, final point. Final point. Final point. So when talking about the property displacement, displacement has a magnitude. How do you find the magnitude of displacement? Again, measure the length of the straight line. Distance means length of the path traveled, but in this scenario also, object, if not you, have traveled in this blue color path only. But displacement means the straight line between initial point and final point. So therefore, if you measure the length of the straight line, it gives the magnitude of displacement. Then remember, displacement unit is meters again. Dimension, since it's a length, capital L. But remember, displacement is a vector. Displacement is a vector. It's a vector. Right? Vector. Then what is the direction of displacement? Always from initial point to final point. See, look at the arrow. So this arrow represents the direction of displacement. If you can measure this angle to this arrow, then that is the direction. So remember, distance means a scalar, displacement is a vector. Okay. Now, to understand more, then I gave a small sample question. Sample question in that PDF. Quickly take the PDF. In that PDF, there's a small sample question. Quickly take the PDF. In that PDF, they ask, in that PDF, yeah, I have given distance means length of the path can be defined as distance, units meters, dimensions simple, sorry, capital L, scalar. displacement means the shortest distance. Highlight always shortest. If you have a marker, highlight shortest. Highlight displacement shortest. Shortest. Highlight. Then sample question, it says that an object starts the motion from A and reaches B. Find the distance and displacement. Find the distance and displacement. If I do that sample question, 3 meters and 4 meters, A to B. So you can also do parallelly. You don't wait until I do. It is kind of quick revision, right? So then, in that case, so now they have given initially object is at A. Object moves 3 meters to the right. Then 4 meters upwards. This is the point B. Final point is point B. Final point is point B. Point B. If you want to find the distance, I told you distance means the length of the path. Right? In object is traveling from A to B along this path. Then what is the length of the path? This length is 3 meters and this length is 4 meters. The total length of the path will be 3 plus 4, 7 meters. So you can write down distance means, simple D means how much? 3 plus 7, sorry, 3 plus 4, that means 7 meters. Then I told you how do you find the displacement. When you find, if you want to find displacement, first decide the initial point. We know initial point is point A. Where is our final point? Final point is point B. Always draw a straight line between A and B. If I draw a straight line between A and B, we know that is the displacement. I draw a straight line between A and B. Okay. Then if I can measure this red color line length, that would be the magnitude of my displacement. Right? Magnitude of my displacement. Okay. Then how can I find this length, red color length AB? We know that since it creates kind of rectangle, we can use Pythagoras theorem. Pytho. We know Pytho. So when we apply Pythagoras theorem, we can say, I say displacement is capital S. Capital S squared, we know, all levels we learn, capital S squared equals, this length is 3 meters, 3 squared plus, this length is 4 meters, 4 squared. Then what we can write down? We can write down 3 squared means 9, 4 squared means 16, S squared. So when you subject S, we know 16 plus 9 means 25, 25 whole root. That means we know displacement will be 5 meters. But remember, since displacement is a vector, if you only write the magnitude, they won't give marks. Because we know you should mention the direction also, because displacement is a vector. Right, therefore, not only find the magnitude, but also you should find the angle, direction. In that case, you should define an angle. Now you want to find the direction of this straight line. So therefore, I consider the angle made from horizontal to this displacement direction is theta. Theta. Then if you can find the value for theta, problem solved. Then what can I do? I can write down, if I consider this right angle triangle, sine means opposite over hypotenuse. I know I can use sine also, because since I know this value is 5 meters, I can use sine. If not, one can use cos, one can use tan. It doesn't matter. Somehow you should find the theta. So I'm going with sine ratio. If you can use cos tan both also if you want. Anyhow, you will get the same angle. So I can say sine theta means how much? Sine theta means opposite. Opposite length is 4 meters over hypotenuse. Hypotenuse will be 5 meters. So then I can say sine theta means we know 0.8. When you subject theta, theta will be sine inverse 0.8. So if you have a logbook, you can find this angle in degrees. Right. So this is the difference between distance and displacement. Okay. If you understand this, that's it. That's enough. Now we are talking about a speed and velocity. Speed and velocity. Speed and velocity. Speed and velocity. Right? Speed and velocity. Okay. Before that, now there's a point important, and they mentioned if an object reaches its initial point again. If object reaches its initial point again, then the displacement of the motion is zero. Right, that is also important point. Please highlight that entire point. Highlight that entire point if you have taken the printouts. Remember. Now I will scrap that point and I will go to speed and velocity. Now, just think in this scenario. Okay. Now, object starts the motion from A, goes 3 meters to the right side, again 4 meters upwards. In this scenario, object stops the motion, finishes the motion at B. Rather than finishing the motion at B, what will happen if this object is coming back to same point? 3 meters to the right, 4 meters upwards. Again, if the object reaches same point, finally, you understand your initial point also, point A. Finally, object reached again point E. Then remember, if an object reaches to the same initial point, then displacement is always zero. Then displacement is always zero. Now you can see this scenario mostly in vertical motion and the gravity questions. Mostly vertical motion and the gravity questions, you will learn what we do, we project object upwards. Then what would happen? This object moves upward and what will happen? This object will come back to the same point again, right? Whatever the location that you projected, let's say now you projected that object from the ground, uh, after traveling upwards, it falls down again the same initial point. Remember, displacement is zero. In both scenarios, displacement is zero, right? Okay, S is zero. So that is the important point you should understand. S is zero. In here also, S is zero. Okay, that is the idea. So then we'll talk about what is speed and velocity. Now, very easy. Now, speed and velocity, the way it is defined is very simple. Now, we can define speed means rate of change in distance. Speed always linked with, remember, distance. But velocity always linked with the displacement. Okay. Let's say, look here. Now, speed. Now, speed means, now just think, this object, very carefully listen. This object moves from A to B. Now, this object moves from A to B. Let's say, I will do like this. Object is at A initially. This is the path traveled by the object, reaches point B. When we measure the length of the path, that is what we defined as speed. You guys know that idea. Sorry, when we measure the length of the path, that is what we defined as the distance. I say the distance from A to B is simple D. Distance simple D. When you measure the length is simple D. It can be 5 meters, 10 meters, 20 meters, something. And you take a stopwatch and you run the stopwatch when object starts the motion from A. Then the time taken to reach B will be, let's say, simple T. Time taken is simple T. So then you can tell within simple T time period, what is the distance traveled by the object? That is simple D. Within simple T time period, distance traveled is simple D. What is speed? Remember always, within 1 second, what is the distance traveled? That is the speed. Always remember, within 1 second, what is the distance traveled? That is we define as speed. Okay, then how do you find out? Within simple T time, distance traveled is simple T. If I tell, let's say, 5 chocolate price is 50 rupees. 5 chocolates, you bought for 50 rupees. If you want to buy 1 chocolate, what is the price? How do you get the price? If you want to buy only 1 chocolate, what is the price? How do you get the price? What you do, you divide 50 by 5. Then you know 1 chocolate is how much? 50 over 5 means it's 10 rupees. 1 chocolate is 10 rupees. Same story. Within simple T time, distance traveled is simple D. Within 1 second, what is the distance traveled? That is what we define as speed. Within 1 second, what is the speed? How do you get the, sorry. Within simple T time, the distance is simple D. Within 1 second, what is the distance? How do you get that distance? You divide total distance by total time. This is what we defined as speed. Right, speed. So remember, speed means the equation is, always remember, speed means, always keep it, when you think the question, You don't think speed means rate of change in distance, but always think speed as distance traveled within 1 second. Okay. So then speed means, remember, speed means distance over time. Distance over time. If we represent this using symbols, capital V equals distance simple d times simple t. So you must learn by heart this equation, right? This is the first equation you get in linear motion. The first equation you get in linear motion, speed equals distance over time. Shall we find the units dimensions, whether it's vector or scale? What is the unit that we use to measure distance? We know distance is measured in meters. Meters, time measured in seconds. Time measured in seconds. Then what should be the units of speed? Units of speed will be meters per second. M always m is minus 1. M is minus 1. Right? Am I correct? So you can write down units as m is minus 1. So units means, remember, m is minus 1. How do you find the dimensions of speed? We know the equation. Equation for speed means distance over time, d over t. We know speed means d over t. If you want to find the dimensions of speed, what do you do? You should take the dimensions of speed equals dimensions of distance over dimensions of time. Then you know what is the dimensions of distance. Since distance is a length, dimension of distance will be capital L. Dimension of time will be capital T. Then I can obtain dimensions of my speed will be LT minus 1. LT minus 1. Also remember, speed is a scalar. Distance is a scalar. Not therefore speed becomes scalar. Just because distance is scalar, not on, no, the thing is, now we know distance is scalar, because of that only we can't tell speed is a scalar. Distance is scalar, speed also a scalar. Speed becomes scalar not because of distance is scalar. Keep in your mind. So scalar, scalar. Now same story can be applied for velocity also. Displacement linked with velocity, speed linked with distance. Now velocity means the brief idea. Velocity. Now I'm quickly briefly I'm explaining. So velocity notation also capital V. There is no any significant difference between symbols of speed and velocity. Both are capital V, capital V. Both are capital V, capital V. Velocity means I take a straight line, because we know velocity is linked with displacement. Let's say an object moves from point A to point B. Moves from point A to point B. A straight line. Let's say displacement from A to B is capital S. The time taken by the object to move from A to B, let's say simple t, simple t. Now we can say within simple t time, displacement done by the object is capital S. What is velocity then? Within 1 second, what is the displacement done is what we call as velocity. Within 1 second, what is the displacement? Within 1 second, what is the distance? That is speed. Within 1 second, what is the displacement? That is velocity. Within 1 second, what is the displacement? How do you find that? How do you find the displacement within 1 second? Within simple t time, displacement is capital S. Within 1 second, how do you find the displacement? You should divide total displacement by total time. This is what we defined as velocity. Velocity. So the equation for velocity is, remember, velocity means displacement over time. Velocity means displacement over time, not distance, displacement over time. So the symbol is capital V equals S over T. S over T. Normally capital S means displacement. Simple D means distance. The equations are very much similar. The second equation you learn in linear motion is velocity equals displacement over time. Okay. Units. Displacement also measured in meters, time measured in seconds. Then what should be the units of velocity? Units of velocity will be m s minus 1. right? ms minus 1. Dimension of velocity. Dimension of velocity also pretty much similar. Dimension is also same as lt minus 1. But remember, velocity is a vector. Velocity is a vector. Displacement is a vector. Velocity also a vector. Vector. Okay. Up to now, I think we are discussing. Start the class around 8:5, 8:6. It's been only 20 minutes. Up to now, everything is very clear answer. If everything is very clear answer, everything is very clear. Right. Great. Yes, yes. Raise your hands. Wait, wait, wait. Raise your hands. Wait. Okay. Right. Then, mm, okay. Velocity done. Okay. Now, remember, you should understand what does it mean by constant velocity. In an exam question, if they mention if an object moves under constant velocity, if not, if they have given if an object moves under variable velocity, increasing velocity, if not decreasing velocity, you should understand about the idea. If you don't understand that idea, you can't think the question. Remember, velocity. Velocity, remember, if an object moves under constant velocity means every 1 second time period, displacement done by the object is same. Right? If an object moves under constant velocity, remember, every 1 second time period, displacement done by the object is same. I will tell you. I will tell you. Give me 1 minute. Give me 1 minute. Yes. Right. Okay. Now, velocity, we can identify there are two types of velocities, right? Velocity or speed. Velocity or speed, you write down velocity, if not speed, because they are pretty much similar physical quantities. Both of them differentiate due to the direction. Otherwise, the idea is almost same, right? Because you can't say that velocity and force are same physical quantity. Somewhat we can't say, but we can say velocity and speed are somewhat similar physical quantities. Now, in questions, you get one type of velocity is constant velocity, constant speed, constant. Then, second type of speed of the motion is variable velocity. Variable velocity, variable velocity. We can divide variable velocities into two different categories. Variable velocity, variable speed into two different categories. One is increasing velocity, increasing speed. Increasing velocity, increasing speed. Other one is decreasing velocity, decreasing speed. Okay, I will tell you. If an object moves under constant velocity, remember, that means if I draw a diagram, remember, let's say there's an object starts the motion, and if they have given that object moves under constant velocity, every 1 second, the distance or displacement done by the object is same. Same. For an example, let's say this is your object. This is your object. This object starts the motion when the time is t equals 0. This object starts the motion when the time is t equals 0. Right? Let's say this object moves under constant speed, if not constant velocity, with let's say 5 ms minus 1. This object moves with 5 ms minus 1 speed. What is the meaning of that? 5m is minus 1 speed means, remember, every 1 second distance or displacement is 5 meters. That is the idea. Do you understand? 5m is minus 1, remember, the meaning is every 1 second distance or displacement is 5 meters. Then tell me, when the time is 1 second, when the time is 1 second, reply everyone, what is the distance or displacement done by the object? Reply everyone. What is the distance or displacement done by the object? When the time is 1 second, reply. Reply quickly. 5 meters. 5 meters. Every 1 second, this object travels 5 meter displacement, 5 meter distance, 5 meter displacement. When the time is t equals 1 second or t equals 2 seconds, distance traveled within a second. The distance or displacement done by the object from t equals 1 to t equals 2 seconds, how much? Again what? 5 meters. When the time is t equals 3 seconds, the next second also it travels same 5 meters. Then this is what we call as constant velocity, if not constant speed motions. Okay, remember, you can use this equation or this equation only for constant velocity motion. Let's say in exam they ask you to find the velocity at this time, right? If the motion is constant only, you can apply this equation or this equation. If you notice that velocity is not constant, velocity is fluctuating, velocity of the car is increasing, speed is increasing. If the speed is decreasing, you can't apply these equations to find the velocity or speed, right? So you can apply v equals d over t or v equals s over t only for this scenario, constant velocity scenario. V equals d over t. So write down somewhere else. If not, v equals s over t. You can only apply for these scenarios. Okay, can apply. Then the second type of velocity is variable velocity. That means velocity can increases, speed can increase, if not speed can decrease. For example, now what will happen? Now you have this idea because day-to-day life we know what is acceleration. We know what does it mean by increasing velocity. We know what does it mean by decreasing velocity. We have the idea, right? Now when the day, let's say now you want to go to school, you want to go for a class, let's say your father drops you, then what will happen? Your father starts the vehicle, then we know vehicle is at rest. That means what is the speed or velocity of the vehicle? Zero, right? Then what will happen when your father starts moving? What will happen with the speed of the car or bike or wheel or whatever? Increases. That means speed is increasing, velocity is increasing. That means what? It is varying velocity, increasing v. Just think your father is moving, and after obtain some time, then what will your father do? Your father go with same speed. Your father go with same speed. Then what will happen? Suddenly your father sees on that what crossover or whatever, right? A student is passing the road, crossing the road. Suddenly what will happen? Your father brakes the vehicle. Then what will happen? When the father brakes the vehicle, what can you say about the speed of the vehicle? Speed of the vehicle is decreasing. If not, velocity is decreasing, right? So I'm talking about that scenarios. Increasing velocity means, remember, something like this. Increasing velocity means, remember, if I draw here like this, right? Your vehicle starts from rest, for an example. Okay, car or bike starts from rest. Then we know initial speed is 0. Initial speed is 0 ms minus 1. Then what happens when the time is 1 second? After 1 second later, let's say speed of the car is, let's say, 5 ms minus 1. 5 ms minus 1. The distance traveled within first second is, what the distance traveled in first second? Let's say 5 meters for an example. Then what happens When the time is 2 seconds, the time is 2 seconds. Within the second, now speed is for an example. Let's say speed is for an example. Huh? These values cannot be accurate. 8 ms minus 1. We know speed also increased parallelly distance travel within second also increased. Now distance is 10 meters. See, because you know that if a vehicle speed increases means what can you say about the distance traveled in that second? Increase, right? Smaller speed means smaller distance traveled. Larger speed means larger distance. That is the idea. When the time is 3 seconds, right? Write on these things, okay? Even you learn this, even you know this, better to write this, because when you write, what will happen? So those points that I revise automatically goes to your mind. Automatically goes to your mind. Therefore, it's okay. You understand, you don't understand, write down this, because this is not mentioned in the PDF also. So therefore, please write down, because rather than listen, rather than read, when you write something, you might also notice some students. That's why there are some students when they study, some students they can study when they read something louder, because if they don't read louder, they can't remember. They can't remember them. But there are some students without reading, by looking at the note, they can remember everything. But most of the students, when they read louder only, they can absorb the points. But there are many students who can remember, who can learn them when they write it again. Some students, they go to the home and they write everything again. Then by writing only, they can revise, they can remember everything. If you write the same thing again, they can remember for a long time. So therefore, always write. That is the good option, right? That is the good option. When the time is 3 seconds, when the time is 3 seconds, you understand. Now speed is what? Now speed is, let's say 12 ms minus 1 for an example. Now speed is 12 ms minus 1. This distance will be, let's say 15 meters, right? Did you notice? Velocity speed, object can move under increasing velocity, increasing speed. That means what happens? Speed is increasing with the time. Speed increases with the time. Parallelly, what can you say about the distance? Distance displacement. Distance displacement also increases with the time. So this is the second scenario, right? So this is what, this is specifically what we call as acceleration. When you notice an object speed increases, when notice every 1 second distance traveled by the object increases, that scenario we call as object is under acceleration. Object is under acceleration. Okay, acceleration, acceleration. After we learn this linear motion revision, I think 15 minutes is enough. Time is 8:45, 9 o'clock. We can stop discussing this one. Then we can take a small break and we'll discuss about vertical motion. Now, when you notice decreasing velocity, if I explain, okay. Now, what you notice, let's say now, already there is a vehicle, that vehicle was moving with a speed of, let's say, 20 ms minus 1. That vehicle was moving with the velocity when the time is t equals 0. That vehicle was moving with a velocity 20 ms minus 1. When the time is 1 second, after 1 second later, you see a drop in its speed or velocity. Now its speed is, let's say, 15 ms minus 1, for an example. Then distance traveled in the first second is, let's say, for an example, 10 meters. When the time is 2 seconds, speed further decreases. Speed further decreases. Now speed is, I tell, 12 ms minus 1, for an example. Then the distance or displacement traveled in that second is, let's say, 8 meters. In the third second, speed further decreases to, let's say, 8 ms minus 1. 8 ms minus 1. Displacement done in third second will be, for an example, let's say 5 meters. These values are not accurate. Okay, we can exactly calculate these values using linear motion equations, right? And then whenever you notice an object speed decreases, velocity decreases, whenever you notice every other second the distance or displacement done by the object decreases, remember, then we can tell that object is under deceleration. That object is under deceleration. Hands up the story, everything is very clear so far, everything, because I am not going to discuss them again. Get the maximum benefit. Hands up, everything is very clear. A brief explanation. Hands, everything is very clear. You write down these things, okay? Deceleration. Deceleration. Okay. Some students, that in your batch, still they are looking for classes. I'm wondering, it's been 6 months since classes are started, 8 months. Still they are finding classes. I'm wondering why. So they want to get the best. You know that when we try to get the best, are we able to get the best? Because we human beings, we don't satisfy with what we have, right? It's common, right? Because especially you girls mostly. In my class, most of them are girls. I don't know why. Um when you go for shopping, let's say when you go and when you want to buy a dress, a denim or a t-shirt or whatever, frock or whatever. So what most of the girls they do, they take so long time. Even they go for a one place, they spend so much of time and they select. They find also this one is better than this one, this one is better than that one. Likewise they find, but finally what they buy, the worst one in that shopping place, the worst dress only they buy, because sometimes they don't satisfied with what they have. So something very similar thing happening in this class story also. Some people still looking for class. I don't know. I'm wondering. 8 months they are looking. I know most of them until exam comes, they look the classes. Don't come the classes every day. They don't come. Right? Then always they put the blame on that teacher is not good, that teacher is bad, that teacher is not, that teacher is dark, that teacher is ugly, that teacher doesn't have a car. Likewise, they put the blame. This is a story. Okay. Right. Okay. Okay, deceleration. This is the idea of overall idea. Remember, you can't apply this equation, no, this equation. You can't apply these two equations for these two stories. If an object is under acceleration, if you notice an object's velocity increases, if you notice an object's velocity deceleration, decreasing, you can't apply these two equations to find velocity or whatever time or something. For these two scenarios, we are using specific set of equations. That is what we call as linear motion equations. Remember, whenever you notice an object's velocity increases or decreases, we are using only linear motion equations. Linear motion equations. Equations. Okay. Linear motion equations are nothing but very simple. There are 4 important equations you should remember. Basically, linear motion equations gives the relationship between displacement done by the object, initial velocity, final velocity, time, and acceleration. I will tell you the story. Okay. Now I raise the board and I'll quickly tell the story. Then you can try all the questions. If not, upcoming sections you will able to understand, because you know that if I discuss, let's say, Newton laws, if I discuss, let's say, now circular motion also we have to apply linear motion equations. Now you understand circular motion part, but when I teach you in that question, there are some linear motion stuffs also. But when I teach you linear motion stuffs, you get stuck. Oh, what is this equation? Oh God, it's very weird. I didn't learn something like this. Then your motivation goes down. If you think that you don't know, you didn't understand, automatically you are that confidence level goes down. So therefore, this is kind of help. This cover up class is kind of help to catch the upcoming lessons, not the previous lessons, because you have recording access. Because starting the classes bit late is not my issue; it's your issue, right? Because you are aware your classes have started, because of your decision making poor. Only you are starting classes later, right? So therefore, you can watch the recordings and you can cover it. But until you cover the recording, until you cover the missed sections, you want to catch the current lessons also. That's why I'm doing this cover up class. Because some my theory students who already enrolled also, they need to cover them. That's why mainly I'm doing this. Okay. Okay. Right. Now the story. Now remember what is linear motion equations. Just take the PDF. I won't stop at 9 o'clock, first part. Because we don't take so much time and we don't discuss. Okay, then I want to teach you. Okay, right. Some stuffs are there to do, and we want to do some test theory questions. Okay. So before going to linear motion equations, we'll do those questions as well. Those questions as well. Now, I told you the units to measure speed or velocity is, we know, ms minus 1. But sometimes in exams, in questions, they can ask uh, to convert kilometers per hour into meters per second, right? Generally, we use units units of speed velocity, that is ms minus 1. Mainly it's ms minus 1. We keep always answers also in ms minus 1, but sometimes we can use kilometers per hour also as the units of speed or velocity. In exams, if they have given velocity or speed in kilometers per hour, if you want to convert to meters per second, how can you do that one? Right? Remember, if they have given speed in terms of kilometers per hour, if you want to convert to meters per second, remember, you should multiply velocity or speed in kilometers per hour by 5 over 18. Remember, 5 over 18 should multiply 5 over 18. For an example, if I tell you, for an example, I will show you. Let's say example number 1, 36 kilometers per hour. They ask you to convert into meters per second. Then I told you to convert. How do you convert kilometers per hour into meters per second? 36 into 508. 508, that idea. Right? Can't do many questions. 5 over 5 over 18. Right? 5 over 18. Then you will get what? If I divide 36 by 18, there are 218. Here it's 1. Here it's 2. Then 2 into 5 means 10 ms minus 1. 10 ms minus 1. Now you know how to convert kilometers per hour into meters per second. Very similar way, sometimes they can ask you the opposite way also. If they have given speed or velocity in meters per second, right? And they ask you to convert into kilometers per hour. In that case, how do you do this one? How do you do this one? Then you should multiply by, remember, 18 over 5. Should multiply by 18 over 5. Learn by heart. Why we should multiply by 5 over 18, 18 over 5? I taught these things in theory class because we can't go deep and we don't have time to explain them. Right? I taught you how this becomes 5 over 18. I told these stories. For an example, let's say, if you want to convert 10 ms minus 1 into kilometers per hour. Example number 2, if you want to convert 10 ms minus 1 into kilometers per hour, then you should multiply 10 by 18 over 5. Then what will your answer? 1, here it's 2. 2 into 18 means that's 36 kilometers per hour. And also we'll do few test questions. Now I will give, I don't give time, just try test questions in that PDF. In that PDF, quickly try the test questions. Test questions. In that PDF, test questions. Do them. In that PDF, do the test questions. So we want to finish it quickly. Test questions. Now test question 1. TT. TT1. TT1. From the knowledge, you can do all the questions. TT1 asks what? TT1 says, An object traveling at a constant speed. Constant speed. I told you, if they mention constant speed, the equation we should apply is V equals d over t. If it is speed, d over t. If it is velocity, s over t. Right? An object traveling at a constant speed travels 3 kilometers in 2 minutes. 3 kilometers in 2 minutes. Find the speed of the object. Find the speed of the object. If I do question number 1, we want to find what? They have given distance 3 kilometers. How do you convert kilometers into meters? Right? If you don't know, I will tell that story also. Remember, 1 kilometer means, remember, if you want to convert kilometers into meters, you want to multiply by 1000. If you want to convert kilometers into meters, you should multiply by 1000. Also remember, if you want to convert minutes, MIN minutes, into seconds, you should multiply by 60. Okay, additional points are additional points. So if I try to find the speed of that question, distance is 3 kilometers, time is 2 minutes. 3 kilometers, 2 minutes. How to find this one? Then I can write the equation. We know equation we learned is speed equals distance over time. We know distance means how much? 3 kilometers. How do you convert kilometers into meters? Multiply by 1000. How do you convert kilometers into meters? Multiply by 1000. What is the time? Time is 2 minutes. How do you convert minutes into seconds? How do you convert minutes into seconds? Multiply by 60. Multiply by 60. Multiply by 60. Then you can write down final answer as what? Here you can obtain something like this now. When you simplify 1 0 1 0 cancel out. Here 3 means 1, 6 means 2. 100 over 4. 100 over 4 means 25. 25 ms minus 1. Hands up who got 25 hands up? Hands up who got 25 hands up? Anyone? Yes, got. Right. So then TT1 is done. TT2, I think I have done few examples. Therefore, I don't do TT2. You do TT2 later. Then we'll go to TT3. TT3. That story. ABC are the 3 points on a straight line. AB is 5 kilometers. BC 4 kilometers respectively. Man runs from A to B constant speed 20 kilometers per hour. B to C 8 kilometers per hour. Find the total time taken to go from A to C. Find the total time taken to go from A to C. Because we should do few questions, then only we can understand how the theory is applied. That's why I'm doing few questions. Okay. When I was teaching this in theory class, I took 4 days, 12 hours. Okay, question number 3, TET3. Now they are telling motion of an object from A to C. A, this point is point capital B, this point is a point capital C. Then A to B, 5 kilometers. B to C, 4 kilometers. Right? Then A to B, 20 kilometers per hour speed. Speed is 20 kilometers per hour. B to C speed is 8 kilometers per hour. In the question they ask, find the total time taken to go from A to C. Now remember, in this story, that object moves from A to B under constant velocity 20 km h minus 1. Right, B to C also under constant velocity 8 kilometers per hour. If the object moves under constant velocity, I told you should apply that equation, S over T equation, if not D over T equation, right? Now, but since A to B stories, since A to B motion is a different constant velocity, B to C motion is different constant velocity, you should apply the equation separately for A to B and B to C. You can't take A to C as one and you can't apply one equation. So since the velocities, if not speeds are different, you want to consider A to B as one part, you want to apply the equation. B to C as another part, you want to apply the equation. Right? So then they are asking us to find the total time because we don't know the time taken by the vehicle, time taken by the object to move from A to B, we don't know. Therefore, I write the time as capital T1. Time taken to move from A to B, I write it as capital T1. Time taken by the vehicle to move from B to C, I take it as capital T2. Capital T2. Just think A to B only, forget about B to C. Don't think anything about B to C. Only think A to B motion. You know the distance, right? You know the distance. Okay. You know the speed. You want to find the time. You know the distance. You know the speed. If you want to find the time, if it is a constant velocity, constant speed motion, you want to apply this equation. So if I apply the equation from A to B, if I apply the equation, what? Speed equals distance over time. Look here. Distance, that is how much? The speed is how much? 20 kilometers per hour. 20 kilometers per hour. Right? Speed. Normally I don't substitute units, but it's okay. Distance, that is 5 kilometers over, I want to find the time T1. I want to find the time T1. Then see here, kilometers cancel out. 25 means here 5 cancel out, here 1, here it's 4. Then you get the time in hours. You get time in hours. What is the time? T1 means, remember, T1 means when you simplify this 1 over 4. If you substitute T1, T1 will be 1 over 4. 1 over 4 means, remember, 0.25 hour. 0.25 hour. Likewise, consider B to C motion. You know the speed, you know the distance. If you want to find the time, you can apply B to C motion, speed equals distance over time. Again, consider B to C motion. Again, consider B to C motion. If you consider B to C motion, if you consider B to C motion, you can apply same equation. Speed equals distance over time. B to C motion speed is 8 kilometers per hour. Distance is how much? 4 kilometers. Time is capital T2. Time is capital T2. Time is capital T2. What they're asking? They are asking us to find what? The total time. The time taken to move from A to C. If you can find the time taken to move from A to B, T1, you found 0.25 hours. And also if you can find the T2, if you want to find the total time, you should add them. That is the answer. Then substitute T2. When you substitute T2, remember you will get 0.5 hours. All simplification, 0.5 hours. Then what is the total time? Therefore, you can write down total time means write down T1 plus T2. T1 is 0.25 plus T2 means 0.5. That means 0.75 hours. Remember, if you want to convert hours into seconds, you should multiply by 3600. If they have given an answer in a question, if they have given time in hours, if you want to convert to seconds, you should multiply by 3600. I think that question is done. Now, I haven't taught you what is average speed and average velocity. Now, briefly, I will tell you. Now, 9:06, I want to finish quickly. We'll take a break also. Within 50 minutes, give me 50-minute time. Then we'll take a break also. Remember, now, generally, just practically think motion of any object, mostly vehicles motion. What happens? Take a bus. Initially, bus is at rest in the bus stop. Then what will happen? After all the passengers get into the bus starts moving. Then what will happen for the speed of the bus initially? Initially, bus is at rest. Now bus started moving, then its speed is increasing. Then let's say bus has obtained the desired speed, then that bus travels under same speed. Then suddenly when someone is crossing the road, the driver brakes. Then what will happen to the speed of the bus? Speed of the bus decreases. So then when you consider the motion of the bus, you noticed speed is fluctuating. Initially speed is increasing, that means bus is under acceleration. Then speed is constant, again speed is decreasing, that means under deceleration. When you consider the motion, speed is varying, fluctuating. But you want to define the average speed. Throughout that motion, what is the average speed? Let's say your marks, let's say now within your class, now now you are there are 6 subjects, there are 9 subjects in all levels, there are 9 subjects. But let's say your marks for maths is 99, and your marks for Tamil or Sinhala or your marks for what? Commerce or history, your marks is let's say 10. Can I tell you are bright? Just because you got 99 in maths, can I say that you are bright? Can I say you are weak just because you got 5 marks in history? You are weak student. I can't define like that, right? Because you are really good at math side, but you are a bit weaker in history side. In that case, exactly get the idea about your talent, whether you are bright or weak. If anyone, we go with average. What you do? We add all the subject marks and we divide number of subjects. Then if your average is good, we can say the student's average is more than 75. Then the student is a bright student. If your average is very low, then we can tell since the student's average per subject is less than 20, therefore the student is not that much bright, student is a bit weak. So same thing is we are doing in here also. Whenever you notice velocity fluctuating, speed fluctuating, we have to go with average speed, average velocity. But remember, average speed means, remember, you want to find the total distance. In this scenario, if they ask, now see, if they ask you to find during this motion, find the average speed, you should find the total distance. 5 kilometers plus 4 kilometers, 9 kilometers. And you should find the total time taken to move from A to C. 0.25 plus 0.5, 0.75 hours. You can find the average speed, remember. Average speed means, remember, total speed. Sorry, total distance. T, total distance. It's not distance. Average speed means total distance. Must include capital T. When you divide total distance by total time, this is what we defined as average speed. I learn by heart this, Learn by heart this, okay? Then what is average velocity? Average velocity means, remember, when you divide total displacement, when you divide by total time, this is what we defined as average velocity. Now simple be in that test theory question, the next part of the question, they ask us to find what? They ask us to find find the average speed of the journey from A to C. You know the equation. If you want to find the average speed, you know, average speed means total distance. Total distance 5 plus 4, 12 kilometers. Total time 0.75 hours. Total time T1 plus T2. Total time is 0.75. You know 0.75 means, you know, that is how much? 3/4. 0.75 means 3/4. So therefore 3/4, it will come to like this. Then you can write down average velocity as how much? Average speed means how much? Average speed means how much? That is 16 kilometers per hour. Story finished. Story finished. Right. Now I will tell you what is this linear motion equations. Then we can finish the last part. Give me 10 minutes, then we can finish the story. Up to now, everything is crystal clear, hands up. Because I'm explaining because I can't go deep. But up to now, everything is very clear, answer. Everything is, I understood everything. Everything is very clear, answer. Very clear. Okay, great. Now, this story. Linear motion equations. This is the most important part in this linear motion section. Linear motion equations. Right. Now, I told you whenever velocity varies with the time, if not when the object is under acceleration or deceleration, we can't apply v equals s over t, v equals d over t to find the speed or velocity or time or displacement distance. In that case, we want to use some modified equations. So just think there's an object moves under acceleration. If not, velocity is increasing. Initially, when the time is t equals 0, that object's, just think initial velocity is u. U means write down initial velocity, right? And this object moves under acceleration to the right side direction. Acceleration. Simple A means acceleration. Acceleration. Then what will happen for the velocity of this object with the time? We know velocity or speed increases with the time since the object moves under acceleration. If it starts the motion with 5 ms minus 1, its velocity increases. 6 ms minus 1, 10 ms minus 1, 20 ms minus 1, 30 ms minus 1, velocity increases. Finally, after simple t time later, let's say this object's velocity is capital V. Velocity is capital V. U means initial velocity, write down. V means final velocity. V means final velocity, write down those things if you don't know. A means acceleration. Time taken to move from here to here is simple t time. Simple t. T equals 0 started. When the time is t equals simple t, final velocity is v. Remember the displacement. Displacement measured from initial point to final point. This displacement is capital S. So basically, linear motion equations give the relationship between initial velocity, final velocity, acceleration, time, displacement. So in theory class, I proved these four linear motion equations, but here I don't prove the four equations. Learn by heart. The first equation is V equals U plus AT. Learn by heart. You must learn by heart. They don't give these equations in your exam. S equals, second equation, UT plus half. Very important equation, this one. Many questions, we have to apply this equation. S equals UT plus half, AT squared. Second one. Third equation, V squared equals U squared plus 2AS. When you practice this automatically, you can remember. When we do questions, you can remember these equations. Last one is S equals U plus V over 2 simple t. Simple t. The last equation. The last equation. Now see, if I ask you, you must learn by heart these four equations. Every equation, how many variables are there? How many variables are there in every equation? 1, 2, 3, 4. There are 4 variables. Second equation, how many variables are there? S1, U2, T time is 3, acceleration is 4. 4 variables. So when you check all 4 equations, there are only 4 variables. Let's say in a question, if you know 3 variables, if they have given U, simple A acceleration, and if they have given time, can't you find the final velocity? You can find, right? This is the idea. Shall we do that TT questions? Test theory question we'll do. Test theory question. Let's do this question. In that PDF, let's do your test theory question 13. In the following problems, object starts at initial velocity u, and travels under acceleration, obtain v velocity after simple t time. Find t. Okay, do the question. So test theory. So you want to find what? You know u is 0 and your acceleration is 3 ms minus 2. And then final velocity, v means final velocity, u means initial velocity. Final velocity is how much? 15 ms minus 1. 15 ms minus 1. What they are asking you to find the time. Then you should select the best equation out of these four. That is the first step. Now look at the given data. You know u, you know a, you know v. You want to find t. First, find an equation involving u, v, a, t. This equation, no, no, no. U, v, a, t means first equation. I should write down v equals u plus at equation. V equals u plus at. Okay. Then final velocity is how much? Final velocity is 15. Initial velocity is how much? 0. Acceleration is 3. I want to find t. Then time is how much? 15 over 3. That means 5 seconds. Done. That is the idea. This is the second one. Simple B, second one. Find v, u is 6. Initial velocity is 6. Then displacement 24 meters. Displacement 24 meters. And then time is 10 seconds. Time is 10 seconds. We want to find what? We want to find the final velocity v. I know u, s, t. I want to find v. What is the equation involving v, u, s, t? V, u, s, t. V, u, s, t. Fourth equation. So when you check the remaining three, all those four variables are not included in all these three equations. This is the right equation. So you can write down s equals u plus v over 2t. S equals u plus v over 2 simple t. What is your s? 24. S 24. What is your u? U is 6. You want to find v only. Time is how much? Time is 10 seconds. Then what you can do? You can divide this by here it's 5. If you substitute 6 plus v, 6 plus v will be 24 over 5. That means 4 point how much? 4.8 equals 6 plus v. When we substitute v, understand your v will be 4.8 minus 6. 4.8 minus 6 means, remember, it's minus 1.2. Remember, velocities can have negative values, right? ms minus 1. Hands up, everything is very clear. Hands up to everything is very clear. Now we are going to stop. Everything is no issue. Now, you know, acceleration means we know when velocity increases, that is what we call as acceleration. But I haven't discussed what is acceleration properly. Okay, I forgot to mention that. Look here. Acceleration means, remember, can you remember how we define speed? 1 second, what is the distance traveled? Acceleration means, remember, 1 second, what is the increase in speed? You are careful, listen. Now just think, there's an object within simple t time, it increases its velocity by, let's say, within simple t time, that object increases its velocity by capital V. Within 1 second, what is the increase in velocity? This is what we call as acceleration. Am I correct? Right, for an example, I tell, look here, there is a car or whatever, its velocity is 10. It was moving with 10 ms minus 1. Within 10-second time period, this one's velocity is, now velocity is, let's say, 100 ms minus 1. Reply everyone. Within 10 seconds, what is the increase in velocity? Reply everyone. Within 10-second time period, what is the increase in velocity? Reply everyone. Within 10-second time period, what is the increase in velocity? Reply chat box. Within 10-second time period, what is the increase in velocity? Any idea? 90. 90, right? 90. Yeah, 100. Initially, its velocity is 10. Now its velocity is 100. Within 10 seconds, this object is increased its velocity by 90. Within 1 second, what is the increase in velocity? How do you find? Within 10 seconds, increase in velocity is 90. Within 1 second, what is the increase in velocity? That is we call as acceleration. That means 90 over 10. That means what? 9 ms minus 2. So therefore, remember acceleration means remember velocity over time. Units of velocity ms minus 1, time is seconds. Therefore, acceleration unit is remember ms minus 2. ms minus 2. Remember dimensions lt minus 2. lt minus 2. Acceleration is a vector. Acceleration is a vector. Done? Okay, I have to do that last question. Then you get an overall idea about this. From this knowledge, you can understand hereafter. From this knowledge, you can understand hereafter. But we'll take a small break and come. Up now, everything is very clear. Hands up, linear motion. That's it. Theory wise, that's it. Theory wise, that's it. Everything is very clear. Can do questions. More video questions only. We can get the right idea. But if I do the question, it becomes a theory class. That's the problem. Very clear. Now, what we'll do now, we'll take a small break. We'll take a break. And how long you guys on the break? How long you want the break? Reply. How long you need reply quickly? Reply. How long you want the break? Reply quickly. How long you need the break? How long? Reply. Yes, I need responses from all of you. Quickly, quickly reply. You guys want 10-minute break, but I will give come at 9:30. Come at 9:30. Okay, I might come at 9:32 or 33 also. Come at 9:30. Right. Okay. 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 Now we'll quickly will discuss this vertical motion and the gravity part also. I don't explain, but okay. On the next section. And tomorrow, 26th theory class will start at 8 o'clock. Okay, 8 to 1:30. I might do because we should finish this hydrostatics and fluid dynamics both. Okay, and also because I'm planning to cover the unit 2 by the end of at least February. Because now we should start unit 3 and parallel unit 5. Right? Okay. Okay. Now I think you have the next PDF also. Vertical motion under gravity. Now comparing with linear motion, theory wise, sometimes you feel the vertical motion under gravity is somewhat complex, but in question wise, it's not complex. Question wise, not complex. You can see very complex questions in linear motion. But I advise you, if it is a revision also now based on this knowledge you can practice questions, because in revision class ultimate goal is quickly we revise the theory and we get into past paper and model paper questions, right? That's why I do this revision for revision students. But cover up class students, what you do from this knowledge, continue current theory classes. Okay, then the if you want to go in deep because you understood within 1.5 an hour, this is kind of overall revision, right? I quickly revise what is important. But I haven't done any complex questions. I have done very few questions to get the idea. So I told you, so this session, Linimo session, I took, I think, 3 4 days, around 1 month. I think I taught this linear motion part. So I taught for more than 12 hours, but here I covered everything within 1 hour. But the why what the remaining 11 hours actually I have done the questions and the deep explanations. So when you have time parallelly, if once a week you plan once a week I will watch 2 recordings. Then 2 recordings means around 8 hours. I will watch 2 recordings per week. Likewise, you plan and you watch them and you cover it properly. So based on this knowledge, you continue current lessons. Then you have enough time to catch the previous missed sections. Parallelly, you can learn the current theory class theory also. So you plan it. Okay. Vertical motion. By the name itself, vertical motion means it's vertical motion, but under gravity. Okay. Vertical motion under gravity. Under gravity. Uh, Now, all your knowledge also important. Now, you know that what is weight. So the another word that we call for weight is gravitational force. That is what we identify as weight. Then if I ask you what is the equation to find the weight, all levels you learn, that is mg, mass into gravitational acceleration, is what we call as weight. Okay. Now, You know that just take any object. When you consider any object, when you throw any object upwards, see, when I throw this pen upwards, what would happen? Somehow that pen comes to the ground. Always this ground attracts any object. What will happen? There is a apple in the apple tree. Once you cut the apple from the tree, what will happen? It automatically falls down. That means it's automatically attracted by the earth. Remember, that means any object nearby the earth, there is some kind of attraction power on any object toward the earth. There is some kind of attraction power produced by the earth towards any object on the earth. That is the idea. That is the idea. For an example, see, if I say this is my ground, this is my ground, and I consider an object, mass of this object is simple m. Remember, any object nearby the earth, nearby the ground, ground creates kind of attraction force on those objects. That attraction force we call as gravitational force, if not the weight. So weight means, remember simply, the attraction force produced by the ground on any objects is W. Weight, if not gravitational force. Weight, if not we call it as gravitational force. Tell me when. Now, we learn forces and Newton laws in next chapter, but you should have some kind of old knowledge because you have done science subject for grade 6, 7, 8, 9, 10, 11, right? So now think, when there's a force acting on an object, what is the result? If there is a force acting on the object, remember that object in that direction, there's an acceleration. Now, you know what is acceleration? Remember, if there is a force acting on the object means there's an acceleration in that direction. Since weight acts on this object of mass simple limb in downward direction, there's an acceleration in the downward direction. So this acceleration we name as gravitational acceleration. Right, this acceleration we name as gravitational acceleration. Because of the weight, just think, because of this attraction force on simple limb mass, what would happen for the simple limb mass? Simple limb mass falls down. That means when it is falling down, you know that its velocity is increasing. Velocity is increasing in downward direction means what? A downward direction, there's an acceleration. So this acceleration we call as gravitational acceleration. In theory class, I discussed detailedly, but no time to discuss detailedly. Gravitational acceleration. Gravitational acceleration. Acceleration. Right. Normally, this g value is gravitational acceleration is normally 10 ms minus 2. It's 9.81 ms minus 2. When we do questions, we take g value is 10 ms minus 2. Gravitational acceleration. So idea is very clear. Objects nearby the ground, when that object is under vertical motion, there is only one force, that is weight. When the object is moving vertically, upwards or downwards, there is only one force, that is weight, mg. Because of that weight, always there's an acceleration on the object in downward direction. That is the idea. That is the first idea. Hands up this idea if you understood. If you understand this idea, raise your hands. If you understand this idea, raise your hands. That is the idea. Okay. Now, when you refer the PDF, gravitational force means the force that pulls an object towards Earth. Okay. Gravitational acceleration means the acceleration at which an object is released under gravitational force. Okay, you understood. Now, vertical motion, types of vertical motion. Okay. Now, in questions, when you do questions, you understand there are different types of vertical motions, but they all are same, but we can categorize into different types. Now, first type of motion is . right? So now let's say now the first type is initially that object is on the ground, right? Initially object is on the ground. Careful listen, every point is important. Then what will happen when you project this object upwards, like this pin? Think this pin is on the ground. On the ground, you are now my hand is the ground, and you are going to project this pin upward direction with a velocity, right? See, projecting. Then initially what happens? Pen has an initial velocity upward directions u, because you know u means initial velocity. Then what would happen for the motion? A pen goes upwards. This pen goes upwards. Then you can understand, you have a sense, right? What will happen when this pen goes upward direction? What would happen for the velocity of this pen? If this pen is moving under vertical motion under gravity, I told you always acceleration is downward direction, right? But this object is moving in upward direction. Acceleration is in downward direction. That means what is in upward direction? Deceleration is upward direction. Keep in your mind, if acceleration is in downward direction, deceleration is in upward direction, right? Then when this object goes upward direction, what will happen with its velocity? Its velocity decreases, right? Because acceleration is in downward direction, but object is going in upward direction. Upward direction is deceleration. That means velocity decreases. So what you can notice, its velocity is decreasing. At different locations, when you mark the velocities, this object's velocity is decreasing. For example, this velocity, let's say 20 ms minus 1. Now velocity at here is 10 ms minus 1. Velocity at here will be 0 ms minus 1. So that is one type of motion. If not, what can you do? What you can do, vertical motion, other type is, already object is at an elevated height. What you do, you fold. This object is released from rest, right? Already this object is at a height from the ground. What you do, you release this object from rest. Then what will happen? The second type. This type 1. This is type 1. You should feel these stories when I explain. Type 2, 0 ms minus 1 initial velocity. It is moving down. Then what can you say about the velocity in this story? Because we know when this object is released, there is only one force, that is the weight mg, downward direction, if not towards the ground. Because of that, always acceleration, gravitational acceleration is in downward direction. That is g 10 ms minus 2. In this scenario, when you release from rest, what will happen for the velocity? When this object goes down, since the acceleration is in downward direction, its velocity increases, right? Its velocity is increasing. Its velocity is increasing. Okay. Its velocity is increasing. Okay. Increasing velocity. 0 ms minus 1, 10 ms minus 1. You can say this as 20 ms minus 1. Okay. So the type 3 you will get, type 3 will be something like this. Type 3. Practically, most of the questions belongs to type 3. Okay. In this scenario, in this example, let's consider this pen. Now you project this pen with a velocity of, let's say, 30 ms minus 1. Consider your hand level as your ground. Once you projected this pen, what would happen for the motion? You can see initially pen goes in upward direction. Pen reaches a maximum height. Suddenly, direction of the pen changes. Now pen starts falling down. So most of the questions in vertical motion under gravity is a combination of these two motions. When you project an object in upward direction, initially the object goes upwards. When it goes in upward directions, velocity is decreasing. Velocity decreasing, 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 decreasing. At the maximum height, remember, velocity becomes maximum. Velocity becomes maximum, suddenly changes the direction, and the object is falling down. When the object is falling down, we understand its velocity is again increasing. When the object falls down, its velocity again increases. So this is the main type that we talk. If you understand type number 3, type 1 and 2, it's nothing. So I explain widely. This is the ground. Okay, this is the ground. Now this is my object. Initially, object is on the ground. Let's say projection velocity is, let's say, u. This object is projected to the velocity of u. Then we know when this object initially moves in upward direction. While moving in upward direction, we know its velocity decreases. While moving in upward direction, we know its velocity decreases. If I represent that also in the diagram, velocity decreases. So I represent the size of the velocity using arrows. Then you understand when the object is going in upward direction, arrow size decreases means consider its velocity decreases. Then reaches maximum height. Remember, at the maximum height, velocity is 0. That is the first important point you should understand. In vertical motion under gravity, at the maximum height, remember, velocity is 0. At the maximum height, velocity is 0. That is the first important point. Then suddenly falls down, suddenly moves down. That means initially it was moving in upward direction. Now this object is moving in down direction. And now this object is moving in down direction. Finally, it comes back to the same initial point where it is projected. But you might be wondering why you have drawn two different paths. Initially, it was moving in this vertical upwards. Now it is coming down along this vertical line. Actually, is this what happens? No, right? Whatever the vertical line it moves in upwards, in the same vertical line moves downwards. Then why I have separated two vertical lines? Because to show the scenario. Because if I represent the downward motion also in the same vertical line, will you able to understand? You don't understand, right? To separate, to differentiate the vertical upward motion and vertical downward motion only, I use two different vertical lines. But if not, it should be same line like this. Object is going in upward direction, same vertical line only. Object should come down. This is a real scenario. But to make you understand, I have separated vertical upward and vertical downward motion as two. Okay. Now, when this object is coming down again, what will happen? Again, velocity is increasing. Again, velocity is increasing. That means arrow size increases. Velocity increasing. I will ask you one question. Reply everyone in the chat box. Now, see, in this motion, object is projected from the ground. Finally, it comes back to the same projection point. Raise your hands. How many of you say displacement is 0 hands? Raise your hands. How many of you say in this motion displacement is 0 hands up? How many of you say in this motion displacement is 0 hands up? 0. Because I told you, if an object is coming back to the same projection point, then the total displacement is 0. Hands up, how many of you say distance of the motion is 0? Hands up, how many of you say in this motion distance also 0? No, distance can't be 0 because when you track the path this object is traveled, there's a distance. Distance can't be 0, but since this object comes back to the same point, its displacement is 0. The next important point, vertical motion, is at the maximum height, velocity is 0. Velocity is 0. When the object is moving in upward direction, velocity decreases. That means upward direction, deceleration. Downward direction, acceleration. When the object is coming down, velocity increases means we know downward direction, there's an acceleration. So it doesn't matter whether object moves upwards or downwards. Remember, acceleration is always in downward direction. That is equal to 10 ms minus 2. It doesn't matter object moves in upwards or downwards. Remember, acceleration direction is always in downward direction. 10 ms minus 2, 10 ms minus 2 is the overall idea. Okay. Now, now, now then when you go to that diagram, now the diagram case 3 mentioned at the maximum height velocity 0. You see, all the points are nicely mentioned in that PDF also. Take that PDF as short note PDF. Then if the object releases at same point, if the object reaches same point, if the object reaches same point, displacement is 0, capital S is 0. Highlight those 2 points in that PDF. Highlight those 2 points. And right side, neglect air resistance, time taken for upward motion, time taken for downward motion, same. When the object goes upward, okay, at the maximum velocity is 0. When the object goes upwards, velocity decreases. It not decreases, it decreases. Deceleration in upward direction, acceleration in downward direction. When object comes downward, velocity increases, acceleration in downward direction. Okay, look here in the story. This story, look here. Look here, I want to tell you one important story. Now, that's it. From this knowledge, we can do vertical motion questions. From the linear motion and this knowledge, we can do vertical motion questions. Now, look here. Now, this story, look here. Now, what I want to tell. I want to tell. Okay. Remember, a very, very important point. Now, in exam, if they mention there's an object that moves under vertical motion, and also if they mention neglect air resistance, if they tell a word neglect air resistance, remember, then you can come to a conclusion about 2 points. If you neglect air resistance, remember, I can't teach deeper. Neglect air resistance. We can tell first point is, remember, if it is neglected air resistance, remember initial velocity is u, let's say final velocity is v. Magnitude of initial velocity n, magnitude of final velocity, they are same. So this is possible when air resistance is neglected. And if this object comes back to the same point again only, okay? If what the object that you projected reaches the same point, if the air resistance is neglected, then you can tell that u, initial velocity, is equal to final velocity v. First important thing. Second important thing is acceleration same. Down direction is g, down direction simple g. That is the first idea. Okay. Now, based on this knowledge, we can do a question. When you do a question, you understand the story. Okay. So we'll do the question, the TT question. TT question. Now, take the TT question. In TT, they're asking, from this knowledge, you can get a good knowledge. Now, I will do this question. A particle is projected vertically upwards from the ground at a speed of 60 ms minus 1. How long does it take to reach maximum height? Okay, I will do this question. So next day, motion graphs, and for cover up students, next day motion graph and projectile motion. Now look here. Now TT question, in TT question simply. TT simply. So what is the projection velocity? That is 60 ms minus 1. Okay, u is 60. G means 10 ms minus 2. At the maximum height, we know velocity is 0. They ask simply, how long does it take to reach maximum height? Initial point is here. This is the point where velocity becomes 0. So therefore, this should be the maximum height from initial point to this level should be the maximum height. Am I correct? If I mark initial point is point capital A, that maximum height point is point capital B. For your understanding, I draw that part only. A to B upward motion only I'm drawing. Right? Initially, object U initial velocity is 60 ms minus 1. It moves in upward direction. At the maximum height, we know velocity is 0 ms minus 1. Gravitational acceleration, we know that is 10 ms minus 2. So we want to find the maximum height. Initial to final. Initial point is here, point A. Final point is here, point B. I want to find this maximum at simple h. Simple h. Then how do you find a simple h? Now remember, now in vertical motion also, you should apply linear motion equations. You can remember we learned 4 linear motion equations. We do vertical motion, projectile motion part only using linear motion equations. That's why initially I taught you linear motion. Without linear motions, you don't understand how to do vertical motion questions. But remember, there are some rules to apply linear motion equations. Now, when you do this in exam, you should tell the people who mark the paper, sir, I am considering the motion from here to here. So I am considering the motion from here to here. I am considering the motion from here to here. I am considering entire motion. Likewise, before you do the question, you should let them understand the motion I am considering is from here to here. That's why I put this point as point A. This is point capital B. So when I do the question, you might have noticed. First of all, I write down A to B motion like this. A to B motion. Right? Then what I want to find? I want to find the maximum height. I know U. If I consider A to B motion, velocity at A is my initial velocity. Velocity at B is my final velocity. If you consider A to B motion, final velocity is velocity at B. If you consider A to C motion, final velocity means this V. It changes. Final velocity, initial velocity changes depends on the motion that you take from where to where you are taking. That is the first important idea. Now tell me, based on this, what is the best linear motion equation? You want to find simple h. But what is the best linear motion equation? What is the best linear motion equation? You learn 4 equations. I will write down those 4 also for your understanding. First equation is we know V equals U plus AT. Second one is we know that S equals UT plus half AT squared. Next one is V squared equals U squared plus 2AS. The last one is S equals U plus V over 2 simple T. What is the best linear motion equation to find the maximum height? We know height is a displacement. Then you know acceleration 10 ms minus 2, you know final velocity V. If you want to find the height, that means you want to find displacement S. What is the best equation? UAVS means this equation. Upward direction you want to apply. Now you don't know what is upward direction story. I will tell you while doing the question. I will tell you what is the story of applying the equation upwards, applying the equation downwards, apply the equation right side, apply the equation left side. I will tell you while doing the question. So you understood the best equation will be upward direction V squared equals U squared plus 2AS. Right? If you don't understand, please ask some questions. You can't unmute and you can't ask because my setup is not compatible to listen what you say. But you can put messages. V squared equals U squared plus 2AS. Hands up. We should apply this equation. Up to now, everything is crystal clear. Hands up. Up to now, everything is crystal clear. Hands up.
Everything. If you understand, hands up. Okay. Now, remember what is the meaning of applying this upward arrow? Right, write down somewhere else if you want. Normally, we apply linear motion equations always in the initial direction of motion. Right, somewhere else. We apply linear motion equations in the initial direction of the motion. Now, you know, in this scenario, this object moves in upward direction initially. Later on, this object moves in downward direction. So remember, every equation, before applying that equation, you want to mention, I apply this equation in the upward direction. I apply this equation in the downward direction. Now, since in this motion, object is moving in upward direction initially, I apply this equation in upward direction. What is the meaning of that? When you apply the equation upward direction, what is the meaning? The meaning is remember, I told you vectors. In this equation, how many vectors are there? Final velocity is a vector. Velocity, vector. Initial loss is a vector. U is a vector. Acceleration is a vector, yes. Displacement also vector. Now, all these four variables in this equation are vectors. The meaning is upward direction vectors are positive. Whenever you notice any downward direction vectors, those are negative. Remember the meaning first of all. The meaning is remember upward direction vectors are positive. Vectors means V are positive values when you're substituting. Whenever you notice downward direction vectors, not velocity, V means vectors. Downward direction vectors are negative. Whenever you see any vector in downward direction, when you substitute the values in the equation, you should use minus. That is the idea. Now see, if I do this question, tell me final velocity means we know 0. If value is 0, 0 doesn't have direction. So therefore, you don't want to bother with the direction. 0 equals initial velocity u. U is how much? 60 upwards. Upwards velocities are positive. Upward vector mean velocity is a vector. Upward velocity positive. You want to put plus. In the plus scenario, you don't want to plus. If you just put 60 also, the meaning is plus 60. Am I correct? If you want to put plus, you can put plus, but no need. Plus, sorry, V squared, U squared. That means 60 squared plus 2 acceleration. But you understand here, acceleration is 10 ms minus 2, but in downward direction. Therefore, downward direction vectors are negative values. You would substitute negative 10. You want to find capital S. Capital S means simple H, height. Because height is also measured in upward direction. See, initial point is here, final point is here, displacement from A to B upward, H. Then when you simplify this, you understand 0 equals 3600 minus 20h. So when you move minus 20h to the left side, 20h must be equal to 3600. Subject simple h. 3600 over 20 means how much? When you simplify this, you will get that 180 meters. Clear? Clear. Right? I can give time and I can ask you to do and we can do, but it takes some time. Simple A part is done. See, that's the way. Now, the most important thing is from first of all, you define in order to find something, define where to where. From where to where you want to apply the equation. What is the equation you are going to apply? What direction you are going to apply the equation? Those are the important things. Those are the important things. Right? That story. Done. Simple A done. Simple B hands up. Anyone finished doing simple B part hands up? How long does it take to fall to the ground again? How long? Hands up. How many of you done simple B part hands up? Now, simple B part. Now, I forgot to tell one important thing. See, in this story, when you project an object from this point, if that object comes back to the same point, and if you neglect air resistance, remember, the time taken to move in upward motion Let's say time taken to move in upward motion is t1. The time taken to move in downward motion is t2. Remember, they are equal. Right? Time t1, t2 equal. T1 equals t2. Okay. If you neglect air resistance, the time taken by the object in upward direction and time taken by the object to move downward motion both are same. Right? Then what is the total time? Let's say A to B motion time taken is 5 seconds. In exams, if they ask you what is the total time taken for the entire motion, what is your answer? 5 plus 5. Upward also 5 seconds. I told you downward also same value 5. Upward 5, downward 5 means 5 plus 5, 10. 10 seconds. So that is possible when you neglect air resistance. Huh? These two become these two possible when you neglect air resistance and when initial point and final point both are same. Okay. Now, if I do simple B, what can I do? Simple B, in order to find the total time, they're asking after what time this object come back to the same point. That means they are asking you to find the total time. So one method is method one is simple B. Method one is what you can do. You can find the time taken to move upward motion. Upward motion time you don't know. You know U, you know V, you know A, but you don't know time taken to move upward motion. Simple T you don't know. So what you can do, you can find the simple T time. Time taken to move upward motion, you can find. Simple T, you can find. If you know simple T, in order to obtain the total time, you want to multiply by 2. Okay. So now a upward motion, you know U, you know V, you know A, you know S also. If you want to find the time, you can use any equation involving T. So one can take this equation. In order to find the time, one can use this equation. If not, one can use this equation also. But I am going with this equation. Again, I'm applying that equation. V equals U plus AT, initial direction of motion, upwards. Final velocities we know 0. Initial velocities we know 60. Upwards, therefore plus. Acceleration is downward direction, therefore minus 10. Time is simple T. So when you simplify, you will get time as how much? Time is 6 seconds. Then tell me what is the total time taken for the motion? Upward motion is 6 seconds. The total time taken is how much? 6 into 2, 12 seconds. So upward 6 seconds, downward 6 seconds, total time is 12 seconds. Therefore, total time is, look here, total time is 12 seconds. But this is one method. But I advise you don't follow this method. This method I don't ask you to follow. Now consider entire motion and get the total time. Rather than taking A to B motion, if you take simple B entire motion, that means A to B to C entire motion. You know initial velocity is 60. When you consider entire motion, what is the displacement? Reply everyone in chat box. When you consider entire motion A to B to C, what is the displacement? Reply everyone in chat box. If you take entire motion, what the displacement? Reply everyone. Abhi Rizvia is there. Then Krishna is there. Fatima is there. Fatima somehow I don't know. What is your name? Then who else? Lakshya Ravi is there. Reply. When you consider entire motion, what is the displacement? Reply everyone. Reply. I don't get replies any. You want reply for sir account, huh? Not Suleiman Nawaz. Reply everyone quickly. No time. No time. Reply quickly. So when you consider entire motion, since this object comes back to the same point. What are the displacement? When you consider entire motion of the displacement, displacement is 0. I'm not asking the distance. When you consider entire motion, since the object comes back to the same point, I told you displacement is 0. Displacement 0. Therefore, remember entire motion when you consider, displacement is 0, s also. Acceleration is always in down direction. Therefore, A is 10, these three data. If you want to find the time, what is the best equation? If you want to find the time, what is the best linear motion equation? Out of those four, SUAT. SUAT means what? SUAT means second equation. Second equation is the best equation. So you want to apply, remember, S equals UT plus half AT squared equation upward direction. Because we know we always apply linear motion equation in the upward direction, initial direction. Half AT squared. Displacement is 0. 60 time is simple t plus half. Acceleration is minus 10, minus 10. Simple t squared. See, I want to find simple t, but there are two simple t terms. Simple t squared. So when you simplify further, look here, 0 equals 60 t minus 10 over 2 means minus 5 t squared. Move minus 5 t squared to the left. It becomes plus 5 t squared. Plus 5 t squared equals 60 simple t. 1 t cancel out. Your simple t will be 60 over 5. Am I correct? 60 over 5 means how much? 12 seconds. See, previous method, you took the time taken to move upward motion. You multiply by 2 in order to get the total time. But in second method, you took the entire motion. But we know entire motion is 0 because most of you can't remember, can't understand. When you consider entire motion, displacement is 0, most of you can't understand, can't remember. Then I apply the best equation. See, I'm getting the same time 12 seconds. Right, simple B. Then simple C, quickly, we'll finish. Now time is 10:16. This is the vertical motion overall idea. Simple C. Do it. Mm. Then simple C, how long does it take to fall to the ground again? Oh, I think questions, I think I made a small mistake. In simply, they are asking, simply, I think I made a mistake, okay? Simply, they are asking how long does it take to reach the maximum height. First, we want to find the time taken to reach maximum height. Okay, I made a mistake, okay? First, they are asking from A to B, what is the time taken? First of all, you want to find the simple T. But first, initially, I found H. First of all, I want to find the time simple T. Simple T, 6 seconds. This should be my part A. This should be my part simple D. Simple B only they are asking the height. Simple B only they are asking the maximum height. Then only I should find simple H. Anyhow, I found the time 6 seconds and height, but first I had to find the time. Then I had to find the height. Then simple C, how long does it take to fold the ground again means the total time. The total time is 12 seconds. Hands up. ABC parts are very clear. I made a mistake. I should explain. ABC parts very clear. Hands up. ABC parts. If you understand, hands up. If you understand what I'm saying, hands up. Can understand? Right. But I think first of all, I should find the upward motion time period. Second, I should find the maximum height. Then only I should find the total time. But I changed the order and I found. Then what? Then simply, what is the speed at which it hits the ground again? I told you, if there isn't any air resistance, and also if that object comes back to the same point, initial speed and final speed, they are same, right? Then U equals V. Then what is the answer for simple D? Answer for simple D will be, that is also equal to how much? 60 ms minus 1. Final velocity 60 ms minus 1. But we can find this using the equation also. If you can remember the story, you can tell, since there isn't any air resistance and since this object comes back to same point, final velocity also should be equal to initial velocity. U equals V. That means answer is 60. But you can do that in equation also. Now you want to find V. Consider entire motion. When you consider total motion, remember, when you consider total motion, look here. If you consider total motion, S is 0. Acceleration is 10. You know initial velocity u is given, how much? U is given 60. If you want to find the v, what is the best equation? VUAS. VUAS means v squared equals u squared plus 2as. So you can apply total motion A to B to C. You can apply A to B to C. You can apply upward direction. V squared equals u squared plus 2as. Then you know your final velocity. We want to find the final velocity. A to B to C means entire motion final velocity. That is what we want to find. We don't know. V squared. Initial velocity is 60. 60 squared plus 2. Acceleration is downward direction minus 10. Displacement is 0. You got it. When you consider entire motion, displacement 0. Therefore, I put 0. Then see, this entire thing becomes 0. Then you get your final velocity 60. See, nicely, nice story. Then, then they are asking simple E, simple E. Hands up who finished doing simple E, hands up. Simple E and simple F, hands up. If you finish doing simple E and simple F, hands up. Okay, I will give some time. I will give 5 minutes quickly. Find simple E and simple F. I'll give 5 minutes. Find simple E and simple F quickly. Find simple E and simple F quickly. Give me 5 minutes. I'll be back. Could you guys try the question? Okay, I'll do it. This is the overall idea about vertical motion. If you have this idea, you can do anything. When I do a question, sometimes you can't try the question by your own, but when I explain vertical motion in upcoming chapters, if upcoming chapters connected with vertical motion, when I describe, you understand this is the story because you know the main story, right? Sometimes you are not able to do the question because you are lacking with practicing questions, but you can understand hereafter. So likewise, come to the sessions 26 as well as I'm telling, come to the sessions and cover these things. Right, cover these things. Always don't rely on the watching recording. Some people ask, some students ask, sir, can you provide the cover up class recordings? Yes, if you have any other class in this time slot, okay, that's fair. But eh, I hope you understand. Okay. So now the last two parts, we'll do last two parts. Then theory wise everything is finished. I want to talk about some special cases, but I'm not going to discuss special cases today because that is somewhat complex. Overall idea, I think we discuss vertical motion and linear motion. So I will do last two parts and then we'll try to stop the class. Simply find the velocity, displacement, acceleration, distance traveled, average velocity, average speed after 8 seconds of the motion. Right? It's a very good question. It covers everything. Find the velocity, displacement, acceleration, distance traveled. Okay. After 8 seconds of the motion. Now, carefully listen to this story. Look here. Now, you know that in this vertical motion scenario, when the time is 6 seconds, okay, when the time is 0, object is at the ground. Object is at the projection point. When the time is 6 seconds, we know that object is at the maximum height. Nee? The time taken to move from here to point B is 6 seconds. Nee? When the time is 12 seconds, we know object is again touches the ground. Then when the time is 8 seconds, where should be the object? When the time is 6 seconds, object is here. When the time is 12 seconds, object is here means when the time is 8 seconds, object should be somewhere here. Am I correct? Am I correct? If I draw that diagram for your understanding, if I draw the diagram for your understanding, I think if I need any height is 180, height is 180. If I do the diagram for your understanding, projection velocity is 60, vertical motion under gravity. So when the time is 8 seconds, when t equals 8 seconds, here is your object. Okay. Right? This is the maximum height point. They are asking first us to find the v, final velocity. You want to consider initial point to this point. I say velocity is v. So you want to find v actually. Right? So then you know u 60. Time is, you know the time also. You know acceleration is downward direction 10 ms minus 2. You know acceleration is downward direction 10 ms minus 2. Then what you can do, you can apply, you know, a, you know time, you know t, a, t, u. You want to find v. So what you can do, you can apply upward direction, v equals u plus at. Am I correct? So you want to find v only. U is how much? U is upward direction 60. Acceleration is minus 10. Time is how much? 8 seconds. Then you are getting your v as how much? When you simplify it, minus 20. What is the meaning of minus 20? Why are you getting minus value? I told you upward direction vectors are positive, downward direction vectors are negative. See your final velocity. What is the direction of your final velocity? Downwards. Your direction of final velocity is downwards. That's why you are getting minus. Because I told you upwards are positive value, downward are negative value. You got negative 20 means the meaning is velocity. Final velocity is in downward direction. That's why you got negative. Okay. Then they are asking, okay, then they ask final velocity. Acceleration is same as always. Remember, vertical motion under gravity, Acceleration is only gravitational acceleration 10 m is minus 2 downwards. And they are asking displacement. They are asking final velocity, acceleration, displacement means initial point is here. Careful listen. Careful listen. Initial point is here. Final point is here. Displacement means you can remember initial point to the shortest distance, initial point to final point, the shortest distance. So you want to find actually this capital S. Am I correct? From initial point to final point, the short distance, vertical distance, capital S you want to find. What is the best equation? Since you know V, since you know time, everything, you can, if you want to find capital S, you can apply S equals ut plus half it squared. It's up to you. If you want to find capital S, you can use S equals ut plus half it squared. S equals ut plus half it squared, upward direction. Then you want to find capital S only. U is 60 upward positive. Upwards are positive. Ni? Time is a scalar. Therefore, vector is not a vector. Ni? Time is how much? 8 seconds. Plus how? Acceleration is in downward direction. Therefore, minus 10, negative minus 10. Time is 8, 8 squared. Then 480 minus 64 minus 640 minus 360. Let me simplify this. I don't give time. I quickly I'll do it. Here 64 minus 640 minus 640 when you divide by 2, how much? 320 ni? Right? Ni 64. 640 ni 64 ni divided by 2, how much? 320. Then you are getting your capital S as how much? 480 minus 320 means 160. 160 meters. Your displacement is 160 meters. Right? Also, they are asking distance traveled by the object. From here to the here, what the total distance traveled by the object? We know the maximum height is how much? Maximum height is, we know, maximum height is 180 meters. The maximum height is 180 meters. And we found this displacement. This gap is we found 160. Then tell me what is this gap? If this gap is 180, this is 160, this should be 20. Reply everyone's chat box. What is the total distance traveled by the object? Reply when you consider t equals 0 to t equals 8 second time period. Within that time period, the total distance traveled by the object. Reply. What is the total distance traveled by the object? Reply everyone. I need response from everyone. Lakshya, reply quickly. Don't you guys stay without replying. Lakshya, reply. Abhi, reply. It can be right or wrong. Always there is one to replying. Reply. It's right or wrong. It's okay. Reply. How much? Still no one. Why? Should reply. If I ask you guys to reply, you should reply actually. Tell me, Fatima, what is the answer? Abir is where? Or the total distance? From here to here. This is 180. This object goes here to here. This part is 180. Then this part is 20. Then total distance is how much? 180 plus 20, 200. Total distance 200. See? Total distance is 200. So total distance is 200. Total distance 200. Then they are asking average speed and average velocity. 8-second time period, displacement is 160, distance 200. I told you if you want to find the average velocity, I told you average velocity means what? Total displacement. Total displacement is how much from here to here? Total displacement is, that is 160 meters. Divided by total time, 8 seconds. Average velocity is how much? 20 ms minus 1. How do you find the average speed? Total distance from here to here. Total distance 200. Average speed, total distance 200. Total time is 8 seconds. Then how much? 225 ms minus 1. So this briefs everything what you should understand. Okay, at least raise your hands. Everything is very clear. If everything is very clear, raise your hands. If you understood everything, then raise your hands. You guys can raise your hands, but you guys can't talk. I'm wondering why. Why you guys can't talk? I'm wondering. Should talk, huh? Should talk. So this is the overall summary. Now we took to around 2 hours because 20 minute break again 5 minutes. Now I think I have done 2 hours. Within 2 hours, what is important linear motion? What is important vertical motion? I explained. But vertical motion, there are some special cases also. You can see in that PDF also I mentioned. But next day, what I do, that important points and projectile motion, motion graphs. That section will cover it in next week. Within next week, I will plan a date and we'll do it. So then today we'll stop for today's session. Today's session is effective hands up if you feel effective. Session is effective hands up. It's effective. So Lakshya, Ravi, next time want to talk, huh? And Fatima and Abi Rizvia, all of them should talk, right? Talk means don't need to unmute and talk. Just put reply. Even say, if I ask you questions, if I ask you a question, what is the maximum displacement? If you don't know the answer, you write on apple. Apple is the answer. What is the total height? Mango. It doesn't matter your answer because you know that I'm the teacher. I know everything, but you don't know everything. You come to me to learn. So therefore, do what I say from beginning to end. Then I will progressively I will improve your skill. I can make that. I have made them for many students. Why who followed what I ask. Right, okay. Then we'll stop and tomorrow theory class we want to cover the hydrostatics. We are starting at 8 o'clock and might do five and a half an hour class because we want to finish quickly. And also 25 theory class also tomorrow Sunday 6 p.m. onwards I'm doing that class. Then today we have paper class also. Today we have paper class at 8 o'clock. Want to finish that book also. I want to send the paper book to next week also. Again, I have now already I posted your tudes, rotational motion and vertical motion under gravity. So rotational motion and hydrostatics fluid dynamic tude I posted 2 tudes, and next week also I have to post the paper book tudes. Okay, right. Then by talk, Lakshya should talk, Abir should talk next time. Then Fatima, I think you are Fatima. Some I don't know what's your name. Put a reply. Who are you? Should reply. Should talk. Should reply. Okay. Okay. Have fun. See you. Bye.